Introduction to Two-Way ANOVA. The two-way ANOVA, or analysis of variance, is a statistical method that allows us to evaluate the simultaneous effects of two categorical explanatory variables, or X's, on a quantitative continuous response variable, or Y. We have already learned about one-way ANOVA. The two-way ANOVA is an extension of the one-way ANOVA since it allows us to evaluate the effects of two categorical variables on a numerical response. The advantage of a two-way ANOVA over a one-way ANOVA is that we test the relationship between two variables while taking into account the effect of a third variable. Moreover, it also allows us to include the possible interaction of the two categorical variables on the response variable to evaluate whether or not they act jointly on the response variable. Take home message. This is what you need to remember. A two-way ANOVA is used to simultaneously, so at the same time, evaluate the effect of two categorical variables, or X's, on one quantitative continuous variable, or Y. Remember, before we just had a Y and one X, now we have a Y and two X's. Cool. How many X's? As many as you want if you have enough data for it. It is referred to as two-way ANOVA because we are comparing groups which are formed by two independent categorical variables. Again, you can have two variables. You could actually have more than two, but at least two. Before we only have one. Now we're adding more. Great. Data. Okay, so we're not going to have any trouble getting our data in because we're using data that is already contained within the package called Palmer Penguin. And so to illustrate how to perform a two-way ANOVA in R, we will use the Penguins data set, which is available from the Palmer Penguins package. Yay. We do not need to import the data set, but we need to load the package first and then call the data set. Remember that you first need to install the package on your device using the install command, then load them into the session using the library command. Eddie, what's going on? Come on up here. Whining. So let's load the package containing the Penguins data. Now you might notice here, I put this little thing, warning equals false. I put that inside these curly brackets. What that does is it sets the, it's like the settings for that chunk, and it's just not going to give us a bunch of red flag warnings because we don't need them. It's fine. Library Penguins, it runs. Notice we did not create a data set in the environment. There's nothing up here, but the data is actually loaded into R. Now, so that we can see the data, we're going to rename the data set. So this next chunk just takes the Penguins data that we invisibly loaded and puts it in something called DAT, which is a nice thing to call your data. I mean, it's kind of generic, but it's easy to type, right? So we run this chunk here, and now we can see up here above my head, there's DAT. There's DAT. There is DAT. What is DAT? What is DAT? So click on this blue circle and you can see that it contains 344 observations of 8 variables. We have species, island, bill length in millimeters, bill depth in millimeters, flipper length in millimeters, body mass in grams, sex and year. Okay, and we can see that species and island and sex are all factors, right? These are categorical variables. A factor is what R calls a categorical variable. So these are categorical variables. And then we have the bill length, the depth, flipper length, body mass, and these are all, well, actually, look, bill length and bill depth are numeric, and then flipper length and body mass and year are coming in as integers because there's just a couple different ways of coding in numbers. Integer, which would often be, what do we call it, quantitative discrete, but it's not actually, it's these are continuous variables, except year. I don't think year would classify as a continuous variable. I think if you wanted to analyze year, it'd actually make more sense to analyze it as a factor because you've only got 3 levels. There's only 3 years. Anyway, on to the lab. Let's get what we got to get done here. We got to get this done. All right. Again, this data set contains 8 variables for 344 penguins, summarized below using the summary dat command. Boom, there's our summary. So handy, it's all done. We can see we've got 3 species, Adelie, chinstrap, gentoo, fat. How cute is that, right? We've got these cool penguins. And they're found around Antarctica, on different islands off the coast of Antarctica and South America. They all look a little bit different. Adelie's just got this little black head. The chinstrap has this looking like a chinstrap on it. And the gentoo, he's got this very regal look to him and this white triangle on his head. So these are 3 different kinds of penguins. Great, we talked about penguins. Yes, we were talking about penguins. Now you can have a picture in your mind when we're talking about these different animals. And they occur on different islands, 3 different islands that the researchers recorded them. Okay, so those are 3 species, the 3 islands, again, all the data. And you notice that for factors, what we get is a summary where we get a count of the number of times this category shows up in our data. So under species, we have 152 Adelie, 68 chinstrap, 124 gentoo, right? And the islands, again, it's a factor. So what we do is we get a count from the summary. But notice how for the numeric data, instead of a count, we get the 5-number summary plus the mean. We get the min, first quartile, median, mean, third quartile, max. And also it tells us if there's some NAs in the data, if there's some missing values in the data right here in the summary. So this is always a good step, always a good step. Do the summary first, and it will tell you a lot about your data. You will also right away see if something has come in as a numeric variable instead of as a factor, or vice versa, because you will have to fix your data. I say this every time, even though we don't always have to do it, just because it will happen to you. And I want you to be aware. Pay attention, do the summary first, look at your data. How many times have I said that? Look at your data, look at your data, look at your data. Okay, we've got sex, and we see under sex here, this factor, we've got females, we've got 165 females, 168 males, and 11 that are missing the data. I don't know if it's like hard to tell male and female penguins. It's hard for some birds. Maybe it's hard for penguins. If you want to know more about this data set, you can run this command, !penguins, and it'll tell you more about the data. Cool, right? It's all there. Now let's answer question 1 so we can get our homework done here. Question 1, what 3 species are included in our data and how many observations do we have of each species? I just told you that, right? You can see that in the summary up here. You can look in the summary and you can see we have 3 species, Adelie, chinstrap, and gentoo, and we have 158, 68, 124. So write the answer there in a complete sentence. I don't need to do it for you. You can do that. Okay. Because I want to get this recorded and sent out. We will focus on the following 3 variables. Species, the species of the penguin, Adelie, chinstrap, and gentoo. Sex, the sex of the penguin, male and female. Body mass, the body mass of the penguin in grams. Those are our 3 variables. Which one is going to be our response variable or independent variable, and which are the explanatory variables? And I didn't tell you what question we're trying to ask, but just based on what I already told you about Two-Way ANOVA, there's only one option for the Y variable. What does the Y variable have to be if you just, the only thing you know about these data is the data type, right? You know that species is a factor. You know that sex is a factor. You know that body mass is numeric. Based on what Two-Way ANOVA is, what has to be the response variable? What has to be the Y? Right? It has to be the one numeric variable. We only have one numeric variable. That has to be our Y. And in that case, that is what we're trying to predict, right? We're trying to predict the body mass of the penguin. We're trying to see, actually, does body mass vary by sex and species, right? So Body mass is the Y. That is the dependent variable. Oops, I made a typo in here. And then sex and species are the independent variables that are the predictors. Okay, so what is the response? I'm sorry, I should put here dependent variable. The response is the dependent or Y variable, and which are the explanatory independent X variables. Okay, so again, I just told you that body mass. So body mass is the Y variable, and sex and species are the X variables or dependent variables, independent variables. The Y variable. I'm going to say Y, I'm going to say response / Y variable, and sex and species are the explanatory / X variables. And the reason we talk about X and Y is you think about, oh, what was this going to look like on our graph, right? What's going to be on the Y axis? What's going to be on the Y axis? Well, body mass is going to be on the Y axis. What's going to be on the X axis? Either sex or species. And then we're going to have to put some color or shape or something to differentiate the other category, but we'll get to that. Got it? Okay, good. Make sure that the explanatory variables are read in as factors in R. If that is not the case, they will need to be transformed to factors. We kind of already looked at that, but just to double check the data type of your variables, you can look at the structure, which is kind of old fashioned of me to do because this was, you know, a habit I got into back in the day before RStudio actually just told you everything in this drop down menu here. But it's a good idea to just look at it and check and see, okay, you know, or if you wanted to put this out as part of your output when you're writing a report, if you're doing analysis for, you know, you're doing the analysis for these scientists. They went all the way to Antarctica and they're exhausted. They need somebody else to like manage this data. So you're doing it, you know, you're helping out with conservation of these species. And you're like, okay, I just want you to know, like I checked it, you know, these are all factors and these are all numbers. And they can look at the report and be like, oh, okay, you did a good job. You did your due diligence and you check the data. Cool.